Okay, so the last conic section that we're going to cover is an hyperbola. So basically, if we had two cones that were inverted on top of each other, we could take a piece of paper and slice it through. And so what ends up happening is we create two parabola shapes, okay? So together, they're either going to both be up and down, or they're both going to be left and right, okay? And so it's not just one, it's not really a double parabola, but you can kind of think of that, all right? And so one is vertical and one is a horizontal orientation. Now, the different parts, the way you create these, it's kind of the same idea as the ellipse. If we would take one piece of string from the foci, like attach it there, and if we would move like a pencil, these lengths would be the same, okay? Now, on the standard form, it's going to look very similar to an ellipse. So the first thing you'll notice is that there is a minus in between. Okay, and that's the only really difference between, is this going to be an ellipse or is this going to be a hyperbola, is the symbol in between them. They do both equal 1, so that is the same, and then both of them have A and B. Now you'll notice whether it's horizontal or vertical though, A is first on a hyperbola, so it is not with respect to which one's bigger. So A is first, and really it's A squared. Now, the same relationship does exist though. Let's change colors. I'm not a big fan. Let's do pink. In the x direction, we get to go A units. So you notice if it is a horizontal orientation, this length is A to the part of the hyperbola, and that is also A. In this one, see how A is first, but that's the Y is first, and so that length is A. Okay, so the same relationship between ellipses and hyperbolas, you look under the letter to get a gauge of the length. The center of the hyperbola is in the middle, and there's nothing drawn there, but you do still want to note where the center is, and that's always HK. Once you find, this is still called the vertex or the vertices, there are still two foci inside that parabola shape, okay? Now, the co-vertices, there's going to be, it's called this imaginary box. So the way we make a box is we use the vertex length A and we use the co-vertex length B. And then we draw asymptotes through the box because that guides how wide the hyperbola is. Okay, so we can find equations of those asymptotes because it's just slope. Okay, now once again, I don't memorize hardly any of this stuff. I don't memorize that. I know what A, B, and C are, and so I use that. Now notice the Pythagorean relationship is not subtraction this time. In order to get the focus inside that hyperbola, you need to add them. And so this is the same as the original, okay, Pythagorean theorem formula. C is the length from the center to the focus. Now, what I do want you to notice is if Y is first, the hyperbola opens up and down. That's probably opposite of what you think, okay? And if the X is first, the X squared, then it opens left and right. So it doesn't really follow the rules that the parabola did because this isn't a parabola. All right, let's go ahead and work some out. So let's get my graph going. In standard form, that means we want this to equal 1. So we're going to go ahead and divide everything by 36. So we get x squared divided by 9 minus y squared divided by 4 equals 1. And that would be standard form. So the center is our HK, which there are no numbers there, so we're at 0, 0. Okay, and that's our center. I don't want to put C because C has a different meaning. Now, our vertices go through the hyperbola. So what I want to know is since x is first, that means, well, usually I think of x going up and down, but x is going to go left and right. Okay? And so I'm going to use this length here. So you always take the square root, and so in that direction we're going to go 3. So 1, 2, 3, that's a vertex. 1, 2, 3, that's a vertex. So we're at plus and minus 3. Now, the other box, I like to make my covertices. So we're going to take the square root, so I get 2. So up 2, covertex, and down 2, covertex. And so I make a dotted box because it's not really there. It's a guideline to draw the hyperbola. And then I'm going to make dotted asymptotes, and it goes through the corner of the box. And so this is how you get the width of the hyperbola. Since we know that we're going to open up left and right, I can use that as a guide. And without knowing other ordered pairs, this is actually very accurate. The foci, that's c length. So c squared equals a squared plus b squared. Since we're adding these, it doesn't matter which one's a and b. We just get to add them in the same order. So c squared equals 13, so c equals root 13. And so remember, that's from the center. So I'm going to go root 13, which is a little bit, it's more than 3, but less than 4. So it's really close. More than 3, less than 4. That's foci and foci. So we're at plus and minus root 13. You should never use decimals, okay? The transverse axis is the longer one. Was that labeled up here? Yep, we did. So the transverse axis is 2a, and so you'll notice a is to get to your vertex. So I shouldn't say longer. It's the one through, I won't say longer. So it's through the vertex. And this is through the covertices. Okay, so the transverse, we went 3 in each direction, so 3 and 3 is 6. The conjugate is the one that doesn't have it. It's going to the covertices, so 2 and 2. Now, the asymptotes. This is going to be kind of nice because we're at 0, 0, so I just get y equals my slope. So my slope is rise over run, so we went up 2 over 3 to get to that point. So it's 2/3 x. Okay. Notice on the table, they do have this h and k if we're not at 0, 0. But it's super easy, and I don't memorize if it's b over a or a over b because I know it's rise over run. Lots of things being brought together. All right, let's look at example 2. So this one's going to be a little harder only because we're not at 0, 0, but same idea. So our center is at -5, +2. All right. So in the x direction, I'm going to go 3. So 1, 2, 3, put a dot, and then 1, 2, 3. And since x squared is first, we're going to open up left and right. So I know I'm going to wait to draw that. I'm going to make a little note here, left and right. So this is going to be a vertex and a vertex. So if I go, I'm going to add 3 and subtract 3. But I have them right there. My covertices, I know it doesn't ask for them, but my covertices are going to be up 7. So up 7, down 7. And so I've got this imaginary box. So I'm going to draw in my asymptotes. So this is going to be a really wide parabola. So here we go. And so that's all dictated on your values in the formula. This should go through there, sorry. Okay, so the foci, I get c squared equals a squared plus b squared. C squared equals 58. So c equals plus and minus root 58. And that's from this value. So I'm going to go root 58 and then root 58 from this value. So I'm changing the x. So I get -5 plus and minus root 58. I just write it together. All right, the transverse axis is the one going to the vertex. So we went 3 and 3. The conjugate axis, we went up 7 and down 7. And so our asymptotes. So we get y minus y equals our slope, x minus x. Okay, and so we know we're using this point, which is our center. So I get y minus 2, x plus 5. And our slope is rise over run. So rise, we went 7. Run, we went 3. So it's plus or minus 7/3. If you want, you can add 2 to the other side, but I'm okay with leaving your answer like that. Oh, I have a lot of examples. All right, example 3, we are going to put this in standard form. So we're going to do some more completing the square. So we're going to put our y terms first since they're positive. So 25y squared minus 50y. Then we'll put our x terms. And I'm going to add the 281 to the other side. So we're going to factor out a 25. Factor out a -9. You do have to. Okay. So now we'll go ahead and complete the square. Divide by 2, square it. So that really adds 25. Divide by 2, which is 3, square it, 9, which really adds a -81. So we get 25y minus 1, 9x plus 3, and then 281 plus 25 minus 81 is 225. So then I'll divide everything by 225 and reduce. So y minus 1, 225 divided by 25 is 9 minus x plus 3. Reduce that. It goes in 25 times, equals 1. So since y squared is first, we're going to open up and down. So our center is at x is -3, y is 1. Make sure you keep those in the right order. That often gets missed a lot. So in the y direction, we're going to go take the square root. We're going to go 3. So 1, 2, 3, and then 1, 2, 3. These would be our vertices. Our co-vertices in the x direction, take the square root, we're going to go 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And I always like to draw my little box. If you have graph paper, this makes it really easy though, just so you know. So then we can draw our asymptotes. I was drawing them dotted because they really are imaginary guidelines. And then we can get our parabola. This is pretty wide too. So our vertices, we went 3. So I'm going to add 3 and subtract 3. It didn't ask for co-vertices, but we do have them. Our foci, c squared equals a squared plus b squared. So c squared equals 34. C equals root 34, plus and minus. So from here, so what is that? It's almost 6. So it's more than 5, but less than 6. So that was 3, 4, 5, a little bit more. 3, 4, 5, a little bit more. So that's a y. So I keep my x the same from the center, and then I get the y value of the center plus and minus root 34, which does not break down. The transverse axis goes to the vertex, so 3 and 3 is 6. The conjugate axis, we went 5 and 5. And then our asymptotes, so y minus y1 equals our slope, x minus x1 of the center. So we get y minus 1, x plus 3. So our rise is 3. The run to the box was 5. So plus or minus 3/5. Whoo, you having fun yet? All right. Example 5. Give us different information. So they tell us the transverse axis has endpoints -2, -1, and 8, -1. Okay, and so we know our parabola is going to look like this. So what that means is we've got x squared first. So I need to find the middle. So if these are 10 apart, I want to go 5. So I'm at 3, -1. So we get x minus 3, minus y plus 1 equals 1. Well, I know in the x direction we went 5, so 5 squared is 25. The conjugate axis, it says, has a length of 8, so that means up and down altogether has to be 8, so I want to go 4 in each direction. So 4 squared is 16. The foci, so c squared equals a squared plus b squared. Well, we know the conjugate is length 8. My other length we said was 10. Let's erase this. Not 8 though. So if we went 4 in one direction and 5 in the other, so 5 squared is 25, 4 squared is 16. So c squared equals 41, so c equals root 41. And that's from the center in the x direction. So we're going to take our center, which is at 3 plus or minus root 41. And then the y value is -1. The asymptotes, well, we know our center is at 3, -1. And so our slope, we went rise over run. So we went rise 4 and a run of 5. So y plus 1 equals plus or minus 4/5 x minus 3. Number 6, they give us some different information. So the foci are at 3, 7, and 7, 7. So that's at 3 and 7, which means we've got to look like this. So they want the standard form. So we know x is going to be first. So I can find the middle though. That's at 3 and 7, right in the middle is at 5. So our center is at 5, 7. So x minus 5, y minus 7. I know from there to there, that's c. So c equals 2. But they give us something else. So we have a vertex at 6, 7. So here is a vertex at 6. So from our center at 5, 7 to our vertex is 1. And that's in the x direction. So 1 squared is 1. So we get c squared equals a squared plus b squared. C squared is 4. A squared is 1 plus b squared. So b squared equals 3. And that's all we need. All right, last example. We want another equation. They give us our asymptote. So I'm going to go ahead and add this 3. Because that's the form that we're used to. They don't have to give us plus and minus. We know it really is there. Oops, why did I write a 3? Because I was talking at the same time. So what we should know is that the center of our hyperbola is at 1, -3. Okay. And then they give us the center. We need to know the orientation. So if our vertex is at 1, -1, this is a vertex, that means we're opening this way. And so y is first. Does that make sense? There's a lot of information here. So our center is at -1, 1, so -1, and then 3, -3, so +3. We know from our center to the vertex is 2, and that's in the y direction. So 2 squared is under the y. So a equals 2. And so remember, it's rise over run. So here's our rise. That means our run is 3. So that's in the x direction. So 3 squared is 9. And that's what we need. All right, go ahead and give your problems a try, and good luck.